Hi everyone, welcome to PharmaGrid. So today we are going to discuss 5 more calculations. So question number 56, a solution is made by dissolving 17.52 gram of NaCl and make up to 2000 ml with water. What is the molarity of the solution? So this question is based on molarity. So here we need to calculate the molarity of the solution. So molarity, which is denoted as capital M, is the number of moles of solute in 1000 ml or 1 liter of the solution. And number of moles can be calculated by this equation. That is, number of moles is equal to weight in gram divided by molecular weight. And molecular weight is equal to sum of atomic weights of atoms in the molecule. Here the molecule is sodium chloride. So in sodium chloride, the atomic weight of sodium is 23 and the atomic weight of chlorine is 35.5. So the molecular weight is the sum of atomic weights of atoms in the molecule. So molecular weight of NaCl will be equal to 23 plus 35.5, that is equal to 58.5. So we have got the molecular weight of NaCl. So molarity is equal to weight in 1 liter divided by molecular weight. In the question they have given a solution is made by dissolving 17.52 gram of NaCl and make up to 2000 ml with water. That is 17.52 gram of NaCl is present in 2000 ml or 2 liter. Okay, that is written here. Here the weight in 2000 ml or 2 liter is equal to 17.52 gram. So with this we can calculate the weight in 1 liter. That is, weight in 1 liter is equal to the 17.52 divided by 2. That is equal to 8.76 gram. So we have got the weight in 1 liter, that is equal to 8.76 gram. And from this, or using this, we can calculate the molarity. Molarity is weight in 1 liter divided by molecular weight. That is 8.76 gram, which is the weight in 1 liter, divided by 58.5, which is the molecular weight of NaCl. So the answer is equal to 0.1497 molar. Next question. 0.8687 gram of calcium chloride is dissolved in 500 ml of solvent. Density of solvent is equal to 0.95 gram per centimeter cube. What is the molality of the solution? So in this question we need to calculate the molality, which is denoted as small letter m. In the previous question we have discussed about molarity, which is denoted as capital letter M. So molality is equal to number of moles of solute in 1000 gram or 1 kilogram of the solvent. Number of moles can be calculated by the equation weight in gram divided by molecular weight. Here the substance or the molecule is calcium chloride. The molecular weight of calcium chloride will be equal to sum of atomic weights of calcium as well as the chlorine. So here the atomic weight of calcium is 40 and the atomic weight of chlorine atom is 35.5. Here in calcium chloride, 2 atoms of chlorine is present. Okay, so the molecular weight will be equal to 40 plus 2 into 35.5, that is equal to 111, which is the molecular weight of calcium chloride. So see the question. In the question they have given that 0.8687 gram of calcium chloride is dissolved in 500 ml of the solvent, that is half liter. So we can calculate the number of moles in 500 ml. Number of moles in 500 ml will be equal to weight in gram. Weight in gram they have given, that is 0.8687 gram divided by molecular weight, that we have already calculated, which is 111. So the number of moles in 500 ml will be equal to 0.0078. So in order to find out molality, we have to find out the mass of 500 ml of the solvent. So in order to find out this, they have given a clue, which is the density of the solvent. Density is nothing but it is the mass by volume. Density of the solvent is equal to mass by volume, that is equal to 0.95 gram per centimeter cube, which is already given in the question. So from this we can calculate the mass. Mass is equal to density into volume, that is 0.95 into 500. 500 is nothing but the volume of the solvent. So 0.95 into 500 is equal to 475 gram. So this 475 gram is the mass of 500 ml of the solvent. That is, in 475 gram of solvent, 0.0078 moles of calcium chloride is present. Okay, this is what we have calculated here. That is a number of moles in 500 ml. That is equal to 0.0078. This is explained here. That is, this 500 ml means it is 475 gram of the solvent. That is, in 475 gram of the solvent, 0.0078 moles of calcium chloride is present. Therefore, in 1 gram of the solvent, so how we will calculate in 1 gram? So therefore in 1 gram of the solvent there will be 0.0078 divided by 475 moles. We need to calculate in 1000 gram or 1 kilogram of the solvent. Therefore in 1 kilogram, that is 1000 gram of the solvent, will be this value multiplied by 1000, that is 1000 into 0.0078 divided by 475, that is equal to 0.0164 molal. Okay, so 0.0164 is the molality of the solution. Question number 58. A 20 ml vial is labeled as potassium chloride 2 milliequivalent per ml. How many grams of potassium chloride is present in 20 ml vial? So this question is based on milliequivalents. So in the question they have given that potassium chloride is labeled as 2 milliequivalent per ml. That is 1 ml contains 2 milliequivalents, and we need to find out the grams of KCl present in 20 ml vial. So therefore 20 ml contains 20 into 2, that is equal to 40 milliequivalents. And here you can see this is equation to calculate the number of milliequivalents, which is equal to weight in milligram divided by molecular weight into valency. So here molecular weight of potassium chloride is equal to atomic weight of potassium, that is 39, plus atomic weight of chlorine, that is equal to 35.5. So this 39 plus 35.5 is equal to 74.5, which is the molecular weight of potassium chloride. And valency of potassium chloride is equal to 1, that is KCl gives K plus plus Cl minus. So from this equation, we can calculate the weight in milligram. That is, weight in milligram is equal to number of milliequivalents into molecular weight of KCl divided by valency. That is equal to 40. 40 is nothing but the number of milliequivalents into 74.5, which is the molecular weight of KCl divided by 1. It is nothing but the valency of potassium chloride. That is equal to 2980 milligram. So in the question, we need to calculate, or we need to find out the answer in grams. So we need to convert milligram into gram. How we will convert milligram into gram? Divide this value by 1000, that is 2980 divided by 1000, that is equal to 2.980 gram, which is the answer, or which is the number of grams of KCl present in 20 ml vial. So next question, what is the milliosmolarity of normal saline? So normal saline means 0.9% weight by volume sodium chloride, that is NaCl in water. So 0.9% weight by volume means 0.9 gram is present in 100 ml. Or we can say that 100 ml contains 0.9 gram NaCl. So this is the equation to calculate milliosmolarity. That is, milliosmolarity is equal to weight in grams per liter divided by molecular weight into number of species into 1000. So here molecular weight of NaCl is equal to 23 plus 35.5, that is equal to 58.5. This 23 is the atomic weight of sodium and 35.5 is the atomic weight of chlorine. And here number of species is equal to 2, that is in sodium chloride, that is sodium and chlorine atom is present. So we know that here weight in 100 ml is equal to 0.9 gram. So what will be the weight in 1 ml? That is equal to 0.9 divided by 100. So next we need to calculate the weight in 1 liter, because see the equation. Here we need to find out the weight in grams per liter. So weight in 1 liter is equal to 0.9 divided by 100 into 1000. That is equal to 9 gram. So 9 gram is present in 1 liter. Now substitute all these values in the equation for milliosmolarity. So therefore milliosmolarity is equal to 9. 9 is nothing but the weight in grams per liter divided by 58.5, which is the molecular weight of sodium chloride, into 2. 2 is the number of species into 1000. That is equal to 307.69 milliosmoles per liter. Question number 60. A solution contains 448 milligram of potassium chloride, 468 milligram of sodium chloride in 500 ml. What is the osmolar concentration of the solution? So when this question is based on osmolar concentration. Here we need to calculate the osmolar concentration of the solution. So first we will calculate the osmolar concentrations of potassium chloride and sodium chloride separately, and then we will add both of this. So the equation to calculate osmolar concentration, which is expressed in osmoles per liter, is equal to weight in grams per liter divided by molecular weight into number of species. First we will calculate for potassium chloride. For potassium chloride weight in 500 ml, so it is already given, that is 448 milligram of KCl is present in 500 ml. So weight in 500 ml is equal to 448 milligram. Now weight in 1000 ml or 1 liter is equal to 448 into 2, that is equal to 896 milligram. And convert this milligram into gram, that is 896 divided by 1000. that is equal to 0.896 gram. So the weight of potassium chloride in 1 liter is equal to 0.896 gram. And the molecular weight of KCl is equal to 39 plus 35.5. 39 is the atomic weight of potassium and 35.5 is the atomic weight of chlorine. That is equal to 74.5. And number of species is equal to 2. That is in potassium chloride, K plus and Cl minus is present. So substitute all these values in the equation for osmolar concentration. So osmolar concentration is equal to 0.896 divided by 74.5 into 2. That is equal to 0.024. So this is the osmolar concentration of potassium chloride. Similarly, find out the osmolar concentration for sodium chloride. That is here it is given that 468 milligram of sodium chloride is present in 500 ml. So like what we have done for this potassium chloride, find out the weight in 1000 ml or 1 liter. So we will get the answer as 0.936 gram. 0.936 gram divided by molecular weight of NaCl. That is molecular weight of NaCl is equal to 23 plus 35.5, that is equal to 58.5. So this is the molecular weight of sodium chloride into 2. It is a number of species, that is sodium and chlorine. 2 species are present in sodium chloride. So we got the osmolar concentration of sodium chloride as 0.032. Next we can calculate the osmolar concentration of the solution. So osmolar concentration of solution is equal to osmolar concentration of potassium chloride plus osmolar concentration of sodium chloride. That is equal to 0.024 plus 0.032. That is equal to 0.056 osmoles per liter, which is the osmolar concentration of the solution. So with this question, we have completed today's calculation series. Thank you everyone for watching this video. Please like, share and subscribe. Have a good day.